Hi, welcome to another video in the probability series. What is the probability of removing a blue ball first and then removing a red ball second? Let's assume these 5 balls are contained in a bag with 3 blue balls and 2 red ones. Well, there are 3 times 2 ways in which a blue ball first and a red ball second can be removed. And there are 5 times 4 ways in which any one ball followed by another ball can be removed. So the probability of removing a blue ball and a red ball is equal to 3 times 2 divided by 5 times 4, which we can write as 3/5 times 2/4. Another way of looking at this is to consider the probability of a blue ball is 3/5, and the probability of a red ball given a blue ball is 2/4. Hence, the probability of a blue ball and a red ball is equal to the probability of a blue ball times the probability of a red ball given a blue ball. Now, this is called compound probability of B1 and R2. In general, if E1 and E2 are 2 events, the compound probability of both E1 and E2 occurring is the probability of E1 times the probability of E2 given E1. But note, if E1 and E2 are independent events, then the probability of E1 and E2 is equal to the product of the probability of E1 and probability of E2, which implies that the probability of E2 is equal to the probability of E2 given E1. Thanks for watching this video. My name is Alistair. Bye for now. Hi, welcome to another video in the probability series, conditional events. A conditional event occurs when the possibility space is reduced by another event. In other words, the events are no longer independent. Let's consider a bag containing 3 blue and 2 red balls. If the first ball removed and is not replaced, then the possibility space for the removal of the second ball is reduced by 1 member. Further to that, if the second ball removed was red, then the number of ways in which this can occur depends on which ball was removed first. Let's consider this scenario. The blue ball is removed first. Then R2 can occur in 2 different ways out of 4 equally likely occurrences. And we write that the probability of R2 given that the first ball removed is blue is now 2/4. And this is a conditional probability that R2 occurs when B1 has occurred, written below. If a red ball was removed first, then R2 can happen in only 1 out of 4 equally likely occurrences. Therefore, the conditional probability that R2 occurs when R1 occurred is 1 out of 4. That is, the probability R2 is conditional and R1 is 1 out of 4. My name is Alistair. I'll see you on the next video. Thanks for watching. Hi, here's another video in the probability series. mutually exclusive events. If we consider two events, we're concerned here with the occurrence of either one event or the other, but not both. We have a set here from 3 going up to 12, and the first event is A, which is selection of a prime number, B is selection of an odd number, and C is selection of an even number. We'll consider A and C. First, A is selection of a prime number. We have 4 out of 10 as the probability, and C, selection of an even number, is 5 out of 10. Written here, P of A is equal to 4 out of 10, and P of C is equal to 5 out of 10. Note that random selections are also known to be equally likely selections. Out of the 10 random choices, the number of selections containing either A or C is 4 out of 5. So the probability of either A or C is equal to 4 out of 5, divided by 10, which gives us 9 out of 10. So in general, if we have the probability of event 1 or event 2, it's equal to the probability of event 1 added to the probability of event 2. Thanks for watching this video. My name is Alistair. See you on the next video. Bye for now. Hi, here's our probability tree, which concerns the go and stop signals. We have the first signal, which comprises 0.4, and then we have the second signal, which we have probabilities of 0.65 and 0.45. We need to complete the stop probabilities. So if this is 0.4, then the stop must be 0.6, since our probability must be 1, the total for both go and stop should be 1. Here again, if you have 0.65, then our stop will be 0.35, and go is 0.45, so this should be 0.55. Now let's go ahead and write out the outcomes. So we have first here, we look at go and go. That branch will give us 4 out of 10 as probability times 0.65, which is 65 over 100. We go along go and a stop. We have go, stop, and our probability is 4 out of 10 times 35 out of 100. If we have a stop and then go, we have 0.6 or 6 over 10 times 45 over 100. And lastly, a stop and a stop. Which is 6 out of 10 times 55 over 100. Well, let's answer some typical questions. If we were to find out the probability that there are 2 go signals, so go and a go, we can immediately read that as equal to 4 over 10 times 65 over 100, and this works out to be 13 over 50. What about the probability of a go? That's the first signal, and a stop on the second. That'd be 4 out of 10, 35 over 100. That gives us 7 out of 50. And lastly, what's the probability of at least one go? So we have probability of a go and a go. We have the probability of a stop, probability of stop and a go. And lastly, the probability of a go and a stop. And this is 13 over 50. Let's write out here 13 over 50 and 27 over 100 and 7 over 50 to give us a total of 67 over 100. So at least one go, the probability is 67 over 100. Thanks for watching this video. My name is Alistair. Bye for now. Hi, here's a problem that uses probability trees. It says here that in the winter, the probability that it snows on any one day is 5 out of 7. So the probability that it snows is 5 out of 7 that it snows. That means there's a probability of 2 out of 7 that it does not snow. And we need to first construct a probability tree and show all the possible combinations for 2 consecutive days. Well, we know that it snows 5 out of 7 and it does not snow 2 out of 7. Let's go ahead and construct our probability tree. We'll start from the left here. We have 2 branches. So snow, no snow. So this is day 1. And probably that it snows. We do know it's 5 out of 7. And 2 out of 7 that it does not snow. Now on day 2, we have another 2 options for each. So if it snows here, we can have snow again, or we can have the option of 2 over 7, which is no snow. And if we start with no snow here, we also have 2 options. No snow, or 5 out of 7, and it snows. And that's our probability tree showing the different probabilities. So following snow, we can have another, let me just make sure this looks like a 7. We can have another snow, a day of snow, or we could have no snow. And following no snow, we could have that it snows or it doesn't snow. So the outcomes, we have a column for outcomes. So here, if we read along the tree here, we have snow. We'll just write S for snow. And no snow, we write NS. Here, coming through this branch, we have snow and no snow. So we here, and we have no snow. Then we can come along here for no snow, and then have snow. So we have no snow, snow. Or we can come along for no snow and have another day, in the next day, in fact, no snow. And now we can calculate our probabilities. Let's write that as just PROB for short. Our probabilities as we go through the branches. So if we look at what the outcomes are, snow and snow, we have 5 over 7 times 5 over 7, which gives us 25 over 49. Here we have snow, which is 5 over 7, and no snow, 2 over 7, gives us 10 over 49. Here we have no snow, which is 2 over 7, and snow, which is 5 over 7. This also gives us 10 over 49. And here we have no snow in both cases. So we have 2 over 7 times 2 over 7 is equal to 4 over 49. So we write that, we write 2 out of 7 times 2 out of 7 equal to 4 over 49. From this we can answer a number of questions. For instance, if you asked the probability that it will snow on both day 1 and day 2, you can read this off from your probabilities, which is going along this branch and then this branch will give us 25 over 49. What about calculating the probability that it will snow on the first day but not on the second day? So the probability that it will snow on the first day but not on the second day is 10 out of 49. And they could ask a number of questions. You could be asked to calculate probably that it will snow on at least one day, and that might just involve a number of probabilities. Thanks for watching this video. My name is Alistair. Any questions, comments or requests are welcome. Please like, follow or subscribe for other videos like this. Thank you. Bye for now.